So in this problem, we're being asked to analyze the dynamics of a yo-yo. This yo-yo consists of a solid disc with radius r and mass m. In our earlier analysis, we used energy considerations to find the yo-yo speed after it dropped a certain distance, but now we're being asked to find the acceleration of the yo-yo and the tension in the string. And then these quantities cannot be calculated using only a conservation of energy analysis, so we'll probably have to do some sort of free body diagram or delve into a sum of forces in the y direction. So in this case, let's solve the first part here, which will be we're trying to find the acceleration, and then we can move on to finding the tension. So to find the acceleration and the tension, we first have to see that the change in theta is actually resulting to 2 pi in the use of the yo-yo. For the velocity, we know that it's equal to 2 pi times the radius over the change in time. And this is equal to the change in theta times the radius, since we know that this is the same thing, over the change in time. And this is all equal to the radius times the angular part here. So the acceleration that we're getting is the radius times the length. So now we can move on to the sum of forces in the y direction. And this is actually going to be the mass times the gravity, the weight, minus the tension, and this is going to equal out to the mass times the acceleration in the y direction, just to specify that it's in the y direction. And then the sum of tension is going to be the tension times the radius, and that's equal to the inertia times delta here. So we have half of the mass times r squared times alpha here. And this is also equal to the mass times the radius squared times the acceleration over the radius, so we can cancel out these radius. And then we're going to be left with the tension times the radius is equal to half of the mass times the radius times the acceleration in the y direction, and we can once again cancel the r's if we divide on both sides. And this leaves us with the tension equaling half of the acceleration, and this is all in the y direction. So that is our tension. And now we can move on to finding the exact acceleration, because we do have the tension already solved. So to find the acceleration, we're going to need the mass again. So we know that the weight is equal to half of the mass times acceleration in the y direction. And then once we cancel out all the masses in this case, and we can take out the y for now, this leaves us with gravity is equal to 3/2 times the acceleration again in the y direction, just to specify. And then once we move around gravity, because that's not what we're solving for, the acceleration in the y direction is going to be equal to 2/3 times gravity. That's how we find the acceleration and the tension.